Hi, everyone, and welcome to our webinar, Introduction to NuoDB. My name is Larita. I'm from NuoDB, and I will be moderating today's webinar. I'm joined by Joe Leslie, who's our Senior Product Manager here at Nuo. Hi, Joe.
Hi, Larita.
And in this monthly webinar, we give this webinar once a month just to provide you all with an opportunity to learn a little bit more about NuoDB and ask any questions that you have. So we'll be introducing you to the benefits, showing you a high-level architecture, and Joe's going to also showcase a little demonstration so that you can get a better understanding of how NuoDB works and some of our core benefits just from an actual visual perspective. At the end, we'll tackle any of the questions that come in through the presentation. But before we begin, I'd like to review a few logistics. Our webinar is scheduled to last about 30 to 45 minutes. It will be recorded. It's going to be made available for replay. You're going to be muted during the call, but there is a lovely panel, probably to the right of your screen, where you can jot down any questions, and we'll answer them either during the presentation or more likely toward the end of it. We'll answer as many questions as we have time for. So with that, I will go ahead and turn it over to Joe. Joe?
Great. Thank you, Larita. And welcome everyone for joining our webinar today. We appreciate you joining us and spending this time with us to learn more about NuoDB. So with that, let's go ahead and get started. We'd first like to start by introducing you to a term you may or may not be familiar with, so we'll cover this first, but the Elastic SQL database. And by elastic, we mean here that it will stretch and it will not break. The idea is that database can scale out and scale in very easily in a very elastic way. And then, of course, it's important to mention that this is a SQL database. So it's a traditional database that uses SQL semantics. Many applications today require this. It is a critical part of the NuoDB offering. So from a high level, NuoDB combines this scale out simplicity, this elasticity that we're describing, delivers continuous availability that so many of our cloud apps require today, but does not leave behind the SQL transactional consistency and durability that so many of the databases of record demand. So that's a high-level view of NuoDB as an Elastic SQL database. Let's go a little deeper and look perhaps at some of the the architectures we've seen over the past. And if we look at these architectures, many of you are familiar with these, but we go way back to the days of the mainframe, and we look how IT infrastructure has progressed over time, right? We go from mainframe into a sort of a thick client server architecture, which was very popular for a long while, but then gave way to a distributed scale out model, very popular. And today, we actually see that being deployed within cloud and microservice environments, deploying containers. But what's very interesting as we look at these architectures over time, we've noticed one piece has stubbornly remained the same, and that is the database. The database largely has remained a monolithic part of the infrastructure that has not changed. It typically runs on large architectures or with expensive clustering options, can run across architectures, but the database architecture itself has largely stayed the same. So as it has stayed the same, and we're moving many of our applications to the cloud and microservices, how can we best take advantage of a database running in the cloud? We're going to start to look at that in some more detail. So what is needed for cloud success when we think of our database running in the cloud? Well, we've talked about these two terms, elasticity and SQL, and well, everybody wants elasticity, and what elasticity delivers is some of these items I mentioned before, but specifically benefiting from commodity, lower cost hardware running in the cloud, this scale out and in capability based on application requirements or infinity. And of course, continuous availability. But at the same time, we don't want to lose the SQL aspects of our application, right? We have a lot of invested in our SQL applications, our many skill sets and SQL code that's existing. It's not throwaway. It's actually something we want to continue to run because we're relying on so many of the benefits that SQL applications provide, like ACID compliance and ANSI SQL standard coding, and a database abstraction layer that allows our applications to write using a simple SQL language. So with these together, it brings us to a quote of what we're really looking for, which is, I want to elastically scale my SQL database to the cloud. So another way of looking at this is, if we think of the traditional RDBMS as a few puzzle pieces locked together, some of these items we talked about, right? ACID, compliance, SQL semantics, and the SQL data abstraction layer. If we think of this as one portion of our puzzle, and yet today we also have another, which are some popular NoSQL types of capabilities that are now brought to market, and this is what we were referring to earlier about this these elastic scale out capabilities, and these are several other capabilities that fit nicely together in a puzzle piece. But how do you join these two pieces of the puzzle together? And that's been the challenge. And really the glue here is this concept of the elastic SQL. Elastic SQL is what's really marrying together the benefits of the traditional RDBMS and the benefits of the scale out NoSQL environments that are also available. So really the elastic SQL brings the best of both worlds available in a single product. So if we go ahead and drill in a little deeper on some of these requirements that we've discussed, and let's see how some of the products stack up and deliver against these requirements. Now, we've talked about the SQL application type requirements, SQL semantics, ACID compliance, and of course the database products do very well there. Right, the traditional database product is easily migrates SQL data to itself and scores very well there, but quickly drops off when we look at cloud deployment types of requirements, and even some of these other use cases that are listed here, like non-relational data or Internet of Things types of streaming of data. But traditional database does very well with things like analytics and driving through OLAP databases and so on, and actually does quite well there. But there is that gap in the middle, just was not designed, does not fit well in a cloud deployment model. Now, if we look at the NoSQL products, they actually do quite well when we look at things like cloud deployment and other use cases, but gets a big red X when it comes to the SQL applications, and that's quite often a non-starter for so many companies and that are moving applications to the cloud, because again, they want to retain those SQL semantics. It's very important that the applications continue to run leveraging the same code base, but really want to take advantage of the new deployment model of the cloud to take advantage of things like business agility and automation and cost savings that we get by moving our applications to the cloud. So we see a few players in this area, and as we look at these players, some of them will migrate SQL apps easily into them. Others do not. We look at like a Google Cloud, Google Spanner and Cockroach. They don't do well in this area, but they actually do fairly well in some of the cloud deployment aspects. But then fall off in other use cases. But when we look at we move to the right, we look at the Amazon Aurora product, does a little better, right? It actually can migrate relational data in. but it does not offer the flexible cloud deployment model, much like the Spanner, because it's locked into a certain cloud infrastructure. And moving to the far right, we see that NuoDB actually satisfies all of the requirements in the SQL apps in cloud deployment model, which is exactly where NuoDB is targeted. NuoDB is not targeted at all use cases, and the ones listed at the bottom, like non-relational or Internet of Things and analytics, is not its hotspot, not the sweet spot. It's really OLT-based transactions. Those applications, NuoDB is going to allow you to deploy those in the cloud very easily, and with the elastic capabilities that we've been talking about: scale in, scale out, continuous availability, retain all those SQL semantics. So just wanted to also spend a brief moment. Sometimes it's helpful to hear how a customer is using NuoDB. So Dassault Systems, large software company in Europe. They provide like design software and AI type software to really cross industry to many large industries like aerospace and defense and many others. And they were faced with a challenge of how are we going to migrate a $3 billion business to the cloud for cost savings reasons, and how do you consolidate all these products and portfolio to an integrated cloud platform? Well, looking over the products and the databases available in the database, they landed on NuoDB and chose NuoDB for a lot of the reasons that we've talked about. It is designed for the cloud. We're going to look at that in a little more detail as we work through the slides, and I'm going to show you exactly how NuoDB runs natively in the cloud so well, providing continuous availability, which was critically important to them, and that elastic nature of scaling in and scaling out based on application requirements, policies, and affinity, and so on. So the benefits for Dassault Systems was significant cost savings over Oracle. That was the replacement product, the product they replaced. And they really recognized that the data layer and their investment in this actually becomes part of their competitive advantage in their offering. I'm going to start to drill down a little more into some of those details I wanted to share about what makes the NuoDB database so unique and why does it run so well in the cloud. So if we look at our diagram here in the middle, we see a legacy RDBMS architecture where typically your query processing and your storage processing is all bolted together in a monolithic database architecture, and you tend to move this along into on larger servers and run your database there. Again, they can run on clustered environments, but it's extremely expensive and doesn't take advantage of commodity hardware and all of what the cloud is offering. Now, when you look at the NuoDB architecture to the right, we see a different architecture. First, we see up at the top in the green is a transaction layer. These circles indicate processes. So these are individual processes that can accept application SQL connection requests and then process the SQL. And in doing so, it has a fast in-memory cache at each TE, and also the TEs can be assigned to the applications in a dynamic nature based on application affinity. So one application may run better on one TE with more memory and so on. So basically each one can be configured based on an application need. Now the lower layer is the durable layer, which is what we call, these are the storage managers, and they're responsible for writing and persisting transactions to disk. So these again, here we see we have 3 different storage managers, which in this diagram is indicating that we have 3 full copies of our database. So in this case, we have 6 transaction engines servicing our applications, and we have a durable storage redundant configuration with 3 storage managers. Typically, they would be perhaps installed across 3 different availability zones. So if you should lose an availability zone, that's okay. You still have 2 others where your database is continuing to process and write transactions to disk. So the important piece here is to also recognize is that they obviously scale independently, right? We have 6 transaction engines. We could have 1, 2, or 3 storage managers, and that's all up to the design of the application and what best suits the need. And that's part of the deployment, is you decide how many transaction engines, how many storage managers, and then even over time, it's very dynamic. You can scale in and scale out these processes, which gives NuoDB this power to elastically and dynamically meet the requirements of a particular application. Okay. A couple other points here made on the slide is it is deployment agnostic, right? Can deploy easily on-prem, in containers, in the data center, in the cloud. NuoDB's processes can be distributed across whatever deployment model is chosen for a given need and application. One other point to make also is at the bottom is this again, a continuous availability concept. NuoDB will remain continuous available. Not only in the event of a failure or some sort of unplanned outage where you lose a zone, but even in the case of a planned upgrade where you would want to process a rolling upgrade. So while, for example, as storage managers, while you're upgrading to a new release of NuoDB, you can upgrade them individually, and you'll always have 2 online. And then once all are upgraded to the new version, then the upgrade finally takes. So that all happens seamlessly to ensure that your applications remain continuously available, even when upgrading the system. So I talked a little bit about the durable cache in the transaction engine. This effectively is the in-memory portion of NuoDB. These caches, they're basically per TE. They're warmed per application as the memory as the SQL is running. It's pulling portions of that memory into cache and allowing for the applications to work more efficiently and faster as the data is now available in memory as opposed to always constantly going to disk. Distribution independence, basically the equivalent peers that coordinate to provide a single logical entity is we have multiple TEs that are going to have distributed caches. If one TE does not have a particular piece of data it requires, it still does not need to go to disk. It has an algorithm that's distributed such that it will then go to its next nearest neighbor and find that data if it does not have that data. So it's a very efficient algorithm to find the data that it needs. It will only go to disk if it cannot find database. It comes with a command line interface. It comes with a RESTful API for integration options. But basically, the administration layer is responsible for the domain management, managing the different resources that are brought together, and each of those resources then host database processes. So the administration layer helps manage that layer, as well as it has another important job, which is brokering client requests. So when an application has a request to join the database, the admin layer using its load balancer, and based on certain application affinity, can then assign a matching transaction engine to then service that application request. So request comes in via JDBC or ODBC driver. It can be any one of these applications that are shown up above. So basically supporting a variety of applications and requests to the database. Those requests come into the admin layer, which brokers a connection to the proper TE to match its affinity and its needs. And it will connect to one of these green dots in the middle, representing a transaction engine. And this is where the SQL is then processed. Should the SQL be a DML statement, like a delete, update, or insert, then that SQL is then passed off to the durable storage layer, to a storage manager, where that transaction is then made persistent to disk. All the while, you'll notice that the TEs and the SMs are sort of drawn within the durable cache box, which is indicating that that is a shareable cache. We talked about that a little earlier, how the TEs can go to their next friendly neighbor and find a piece of data to always provide the most efficient path to a data element, which we call atoms, and then process those atoms. Okay. So looking a little even further into a logical diagram here, we see in the yellow box, we have a network diagram that kind of shows how these pieces are connected. So again, now that you're getting familiar with NuoDB, we see our familiar transaction engines highlighted in the green bubbles, and connected to the network. We also see the storage managers indicating that they either have local disk, they can be in the cloud. This is the durable to disk portion of NuoDB. But we also have some bubbles that are indicated that aren't quite filled in yet, and that's indicating that scale out capability. While they're not yet provisioned, they are available at the click of a button to go ahead and spin up more TEs as the application may need to increase throughput during a period of time or season of the year. And likewise with the storage managers, if additional durability is required, they can easily scale, and again, they scale independently. Okay, at the top we see the applications connecting in to NuoDB, and once they've brokered their, they've received a TE from the admin layer, these solid lines from the application to the TE are indicating it is a direct connect. So they're basically now communicating directly on a port, directly to the database, to again improve efficiency while those applications are processing SQL. Okay. What we have here, we're getting to the part of our demonstration where we're actually going to get to have a little fun and play with the product. But before we do that, we want to sort of, provide a picture of exactly what we're going to show today. So today we're, and I'm going to demonstrate this on a single node, Red Hat instance. But what I'm going to do is I'm going to show what NuoDB, how you would deploy it if you were deploying it within 3 different availability zones. And for this demo, in zone 1, we're going to have 1 TE and 1 SM. And that's enough to run a database. That's all you need, 1 TE and 1 SM. But our application, we're going to demonstrate how you can make it durable across geographies and zones. So in zone 2, we're going to bring up another transaction engine and another SM. So now, if we are to lose either a TE or an SM, that would be okay, because we still have 1 TE and 1 SM left, and that's all we require to run the database. Now, in this case, we're going to go ahead and bring up a 3rd zone. We're just going to put a TE out there for some additional application transaction processing power. But we're not going to put an SM there because we already have 2. And for this particular application, 2 will be sufficient. Well, we're going to be protected should we lose an SM. We have another. Just highlighting a little more detail about this broker layer, we see that highlighted in this greenish color, and that's what we're labeling there, the load balancer. So each application connects in there first, based on its request of what it wants to prioritize for a TE, what we would call application affinity. It will then connect to the exact TE that matches that affinity. And if it can't find one, it will go down a hunt list, basically showing how it prioritizes one, but then will connect to the next one and to the next one based on what's available to the system. And we'll get to demonstrate all that. So with that, we're going to go ahead and switch over to our demonstration.
I have to get out of here.
There we go. All right, now we are in our demo environment. Hopefully we can all see that okay. And so I've popped down into a Linux command line prompt. And what I'm going to do is I'm just going to run a command. Now this is a script. Basically what it does is it runs the nuocmd command. This is the command language that provides all the database lifecycle to create databases and shut down databases, restart databases, and all that good stuff. So what this script does, it is going to deploy NuoDB, and we're basically going to show how quickly you can stand up a NuoDB database system. This particular one, what these numbers indicate is I'm asking for one region, but within that one region, we are going to have 3 zones, just like we spoke about in the previous slide. And in those 3 zones, we're going to ask that 2 of them are made durable to disk. So that means 2 of them will have storage managers. And my database is going to be called test, and its login credentials will be DBA for username, and its password will be goalie. So let's go ahead and kick this off. And we can see now it's already starting to create that admin layer we talked about. Those are those brokers. Each one of them will be responsible for a zone, zone 1, zone 2, and zone 3. And our script is already off busy creating zone 1. We see that in zone 1, it's created an SM and a TE. You see that here. And now it's creating zone 2. And zone 2, it has also created an SM and a TE, just like we asked for. And if you recall, zone 3 was just going to get 1 TE. So we can see that it's already done creating the database. And we have a convenient command that can just show us what we created. So there we see our 3 admin services, what we described earlier as brokers. Each one of them will be responsible for managing a zone. And then we see that we have one database in our database section, right? We decided to call it test, and it is in fact running. And we see that in zone 1, we have a storage manager and a TE. And in zone 2, we have a storage manager and a TE. And finally, in zone 3, as we requested, 1 TE. So before we go and create more data, and let's just go look at what a brand new NuoDB database might look like within a graphical SQL run tool. Today, I'm going to be running dbviz. You may have your favorite, but really NuoDB is happy to work with any JDBC or ODBC compliant graphical SQL run tool. So if I reconnect, let's go ahead and reconnect now that we've created a database. And if I open up the schema, so we see it successfully created. And the only thing that's in there is the system schema, right? System catalog. That's all we expect. That's all we did is we just created the database. But let's go ahead and do some more. Let's go ahead and create. Let's go ahead and create a database. So we are going to create a hockey schema. This is a test schema that comes with NuoDB. And our database name is test. And we know that we're going to log in using DBA and goalie. So we're going to go ahead and create this database, and this database is going to give us some data to play with, right? It's going to load some player data, it's going to load some scoring data, and some team data, and so on. This will just take a moment to run. Now, what's happening here is this data is, if I switch back to the other window, this data is loading into both SMs, okay? So remember, we're running now in a containerized environment. Each one of these processes, the 3 admins, and the 1, 2, 3, 4, 5 database engine processes are all running in their own containers, and the data that we just loaded into both SMs. So we are now durable. Should we lose an SM? It's okay. We have another, right? And environments like OpenShift and Kubernetes will enforce environments like this. Should you lose a process, those orchestration products will then simply replace that process, picking up their existing storage, what we would call persistent storage, and your application remains continuously available. So let's go back to our run tool and go ahead and connect again, because we've now just loaded some more data. So if I open this up, we would expect now under schemas to see hockey, and there it is, right? Hockey schema. If I click on the hockey schema and I open it up, and now we're starting to see a lot of these things you may already be familiar with as a database expert or person, DBA or application developer. Things are starting to look a lot like a SQL database, right? I've got tables and columns and indices and foreign keys and primary keys, entity relationship diagrams that you're already familiar with and that you enjoy working with as you design your applications. But we can also run SQL. So why don't we do a little bit of that? If we go over to a window where we can run some SQL to give you a flavoring, I'll go ahead and connect to the hockey schema and show off some of the SQL capabilities of NuoDB. Now, we talked about earlier SQL semantics and NuoDB's compliance to the standard. Wanted to demonstrate for you today just, a variety of ways we can write SQL, right? We all know SQL language is very rich and robust, and you can write SQL in a variety of ways. I'm going to assume your applications some may be older, using SQL 89 standard. In this case, I'm showing here, you'll notice the from clause is joining all the tables on the from clause. This is an older standard. But NuoDB is quite happy to run older SQL, and there you see it's gone and it's returned the data. This particular data is showing us top goal scorers in a single season, and we see that Wayne Gretzky was top scorer in a couple of years, 81 and 83. We see Brett Hull did very well in 64 and in 1990. But we can now go and run that same SQL, but instead of using the older syntax, we may use some of the newer join on condition syntax. Same SQL produces the same results, but different SQL. So again, we're trying to demonstrate here, regardless of your application, when it was written, the SQL standard it uses, NuoDB is quite happy to run that SQL. Likewise here, we have a third sample. It will produce the same result, but this one happens to use the join with the using clause. So we'll go ahead and run that SQL. So I would encourage you to download our community edition and have fun with it. You can fire up a tool like DBViz and start running your SQLs against the database, sort of just as I'm doing here today. Run the create scripts and create some schemas and have fun with the product. But now let's go back, and now what we're going to do is we're going to run some connections and run some sample SQLs against the database and see just in more detail what I've described about load balancing across TEs, and in the event of a failure, how NuoDB will continue to process the application. So I'm going to go ahead and run a sample application. This one's just called Run SQL. And what I'm telling you, robin selector, as we call it, and it's going to round robin, but it's going to prioritize regions. Now, if you recall, we have zone 1, 2, and 3. And what we're doing here is we're prioritizing. We're saying if a TE exists in zone 3, go ahead and give me that TE. But if zone 3, for whatever reason, is not available, then go ahead and give me a TE in zone 2. And then should zone 2 not be available, then give me a TE in zone 1. So this is effectively what I was describing earlier as a hunt list. And, you know, if none of those 3 zones are available, the comma star it's all wildcard based and expression language based. It just says those 3 zones aren't available, you know, give me any TE. I just want to connect to the database. Okay. So if we go back, if you remember this screen here where we showed our database running, because we're prioritizing zone 3, we see that our TE is called test TE4. So since we're prioritizing region 3, when I hit carriage return and this application runs, I'm going to immediately expect that it's going to deliver me back a connection to TE4. So let's go ahead and run. So it's connected, and you'll see, like a good citizen, what it's doing is it just keeps running connections to the database, but you'll see each one of them is being connected to TE4, right? Exactly what we asked for. Now, let's go ahead and insert some failure scenarios into our system. If we were to shut down a zone, so let's go ahead and shut down zone 3, right? Because we're prioritizing zone 3. We want this application to connect to zone 3. Yeah, in fact, the application may run from zone 3, and that's why we're prioritizing that way. But if zone 3 should go away, or at least the database nodes within that zone should go away, we would expect it to then connect to zone 2. Now we can see in zone 2, the TE is test TE3. So as soon as I remove this zone, I'm going to expect NuoDB to very quickly switch over to zone 2 and provide me TE3. Here we go. We just dropped that whole zone, and look to the left, we see our application that continues to run, very happy to continue to run, but now instead of connecting to TE4, which it cannot any longer because we dropped that zone, it's now connecting to test TE3. Our database just got smaller, right? When I do a show domain summary, we see zone 3 is now gone. Let's continue down this path, and let's drop zone 2. Now remember what we said earlier, as long as we have one SM and one TE, our database is up, running, our applications continue to make connection requests and process SQL. We're going to drop a significant portion of the database here, right? We're going to not only drop a TE, but we're also going to drop one of our durable SM copies. But that's okay, because we'll still have one left. So once we run this command, I'm going to expect our application will immediately bounce over to test TE1, right? That's the TE that is in zone 1, right? So let's go ahead and do that. So we just killed off that second zone. So we've just taken on a lot of failure in this database system. Yet, we look to the right, we have not hiccuped at all. NuoDB continues to process application requests, and we see as the times change, 57, 58, 59, it's happy to connect to this database. Why? Because we still have one SM and one TE running. So database is up and running. You'll notice it is reporting that it's saying, oh, I am waiting for an archive to attach, because NuoDB has figured out that, oh, I dropped zone 2, and zone 2 did have a durable copy. So it's indicating to whoever runs this command, you have an SM that's not out there running currently, an archive, that you can start up if you would like on any given admin service. So now that we've dropped our database down to zone 1, let's go ahead and restart our database again and watch how that load balancer starts to recognize how zones are coming back up, and will, as soon as they're back up and live, the application will honor that policy and switch from test TE1 back to these other TEs that it creates. So let's go ahead and start the database. So we'll go ahead and start NuoAdmin 2, right? This is zone 2. That's our admin service in zone 2. Now, when I go ahead and start this, it's going to go ahead and immediately recognize, oh, you've got this SM that's out there running. Do you want to start this archive? Sure we do. Let's go ahead and start this archive. And now we can start it anywhere we want, okay? But we'll go ahead and start it again in zone 2, okay? And we can see it's quickly started an SM and a TE. Now, if you look to the left, already in just seconds, we see now, oh, it changed from TE1. Notice the time has changed, 52 seconds, 54 seconds. The application is now happy to switch over to zone 2. When we do a show domain summary, we see our database is scaling out again, right? We see that it's now increased in size. We now have 2 SMs and 2 TEs. So we're durable. Should we experience a failed process, still okay, right? Because whenever we still have 1 SM and 1 TE, the database is running. Let's go ahead and target and get back to our production goal, which was to run 3 zones. So we could start database, and this time we're just going to start a TE on the 3rd zone. And we are not going to start at SM in this event. It's just going to go ahead and start a TE. It did not have another SM to start. And if you recall, we said zone 3 was our priority. And in zone 3, it started a new TE called test TE7. If we look to the left, to no surprise, we see that our application is now quite happy again to connect to zone 3, because zone 3 has been restored and brought back to production serviceability. So that was a lot of fun. We got to show a lot there. Let's switch back to our slide deck. There we go, and we're going to go into presentation mode. And yeah, let's just review what we saw, right? We saw how simple it is to deploy a NuoDB database, right? I was able to deploy NuoDB in containers, demonstrating across how it would be across multiple AZs, multiple zones, and how easy it was to add and actually remove database processes. In our case, we killed off some, but our database continued to run. We showed the automatic load balancing capability based on application affinity, right? We said we want to connect to zone 3 first, and if zone 3 is not there, we want to connect to zone 2 and then zone 1. So we demonstrated how flexible NuoDB is per the many application types you may have. You may have several hundred different applications connecting into the database, and each one could have a different affinity. You have that ability to control. And all the while, in the event of failure, we showed how NuoDB was continuously available. We, of course, had a little fun showing NuoDB in the DBViz product, the graphical SQL run tool, where we showed full support for SQL, including variations in the SQL syntax. So I hope you've enjoyed our demo today. I'm going to go ahead and move to our next slide here, where we're just going to summarize that as you look at your application needs and upcoming projects, if you are looking to do any of these listed items here, you're migrating and managing SQL applications, migrating them to the cloud, looking to achieve scale out and simplicity, like we've talked about, this elasticity, this ability to stretch and not break, and provide continuous availability to your applications, and yet you still require that that SQL transaction consistency and durability, then NuoDB is an excellent database for your organization and a choice to host your application's database requirements and needs.
Great. Joe, thanks so much for both the presentation as well as the demonstration. We've had a couple of questions that have come in during the conversation. If you have any others that you haven't asked, please feel free to answer them or ask them rather in the GoToWebinar control panel. So the first one, you showed a couple of different SQL statements. How closely in general does NuoDB conform to the ANSI SQL standard?
Yeah, great question. So NuoDB is what I would consider a superset of the ANSI standard. Many databases have implemented the standard, and they all implement in a slightly different way. Our design goal was, as you move your SQLs to NuoDB, and I'll give an example of this. Our goal is that you would modify that your need to modify SQL would be greatly reduced. So we adhered, and I mentioned some of the standards of SQL 89, and all the way up to SQL, 2002, and as I showed the different join clauses in 2003, Windows functions that were introduced later. We continue to review the standard and implement the functions as they come. Now, here's an example. You may use either date or mathematical or string functions within your SQL. Many of the databases have implemented these differently. For example, concatenation, right? Some databases use the concat function. Others will use the double bar function. NuoDB is a superset. It supports both. So regardless if you're moving your application from either a SQL Server or a MySQL or an Oracle, with regard to these functions, our goal is to support those that were already coded from your original source database SQL language. Okay, so hopefully that will answer the question. We adhere to the very closely to the standard. In our documentation, we actually show you as well. You can look up different clauses within the SQL standard and show what's supported and what's not. You'll find that we adhere very well to the SQL standard, and as I described, I believe is a superset supporting other vendors' implementations. Great.
We actually have a couple of questions here that are basically asking the same question. In a database, does each SM have to have a full copy of the data, or is the data partitioned or sharded across multiple SMs? Like, how does that work?
Great question. What we showed today, this is an intro to NuoDB. So what I was showing is each SM is a full copy of the database. But as our database grows in size, that may not be possible. And so NuoDB has an abstraction layer, which we call storage groups, that effectively implements what many of you would be familiar with, which is a database partitioning scheme. And we partition based on range and value, much like all the other databases. But what NuoDB does that's so special and unique is it provides a single logical view. So it's not a shard where you're running separate databases and your application requires the knowledge of where to go get that data. NuoDB fiercely holds to a single logical view. When you write the SQL, you don't need to know where the different tables reside or portions of those tables. That's all handled through the storage group abstraction layer. If you'd like to look into that in more detail, you can search our online documentation, which is publicly available, and search on storage groups and table partitions. It will explain that feature, but effectively what you're allowed to do is then spill over your data from a single SM into other SMs, because those SMs are now assigned to storage groups. And you decide where you want your data to be stored, in which storage group. Storage managers then service those storage groups. And that's the kind of the simple paradigm that NuoDB uses to allow you to scale your database beyond that single disk system and spill it over to other storage managers.
Great, thank you. What is the minimum recommended configuration for NuoDB?
Yeah, minimal configuration. So we can answer that in a few different ways. I run it. For dev and test, you can run it right on your your Linux server. I run on a just a regular 8 processor, either MacBook or Linux server with 8 gig of memory as a minimum. So I have 16 gig. But as you deploy into larger environments, we recommend more than that. So again, I'm running 8 processors, very minimal disk required. But again, that depends on the size of your database and the memory and CPU I've mentioned. So if you want to review though our system requirements, again, that is documented based on what your needs may be, and we'll make suggestions as your requirements need. You may need to implement larger systems. Typically, we see customers implementing 30, 50, 60 gigs of RAM on the TE nodes just to take advantage of that durable in-memory cache that we mentioned. So today, I only ran 2 gigabyte caches for those TEs. Many customers support much more.
And then from a peer configuration perspective, in terms of the minimum production for TEs and SMs, is there a minimum number of TEs and SMs that you'd want?
Absolutely. We would recommend what we tend to call our 2x2. That gives the durability. The minimum durable configuration is a 2x2, which is 2 TEs and 2 SMs. Once you do that, you are all set. You can sustain a failure in either your transaction layer or your storage manager layer, and your system will continue to run just as we demonstrated today in our little demo. In fact, we mentioned earlier Dassault systems. They run an army of 2x2 configurations. They have hundreds of NuoDB databases, and they just love 2x2, and they run many of their applications against these 2x2 configurations.
So another question here is, if we're running in multiple availability zones, is it possible to focus the data in one zone or another? You've got different applications running.
Yes, absolutely. So using that application affinity, if you recall when we ran that Run SQL app, and I showed an expression language where we prioritized the regions, and I said, prioritize zone 3, zone 2, and zone 1. So that means that application is going to go to zone 3. And it will fiercely try to connect to zone 3. Only if a TE is not available will it then fall back to those other zones. So yes, you can prioritize a particular zone.
Great. It looks like that, oh, sorry, one more. How easy is it to migrate an existing database to NuoDB?
Great question. So you'll notice when we were reviewing the requirements for SQL requirements, migration was one of them, and NuoDB is one of the systems that can easily migrate data. It will migrate data from any of the major SQL databases, MySQL, Postgres, Oracle, SQL Server, DB2, so on, simply by running our migrator utility. And what it does is it connects to the database, the source database via a JDBC or ODBC connection, and will extract this schema details and rewrite that into the receiving NuoDB schema. But the smarts of that is that it's looking at each one of the source databases, their data types, and then translating that into the NuoDB receptor data type. So you don't have to worry about any of that. It will simply read the schema, write the schema to NuoDB, and then it will start loading the data from the source database into the new schema that was created. And in fact, we might even have like a blog and a demo up on our site on migration.
Yes, we certainly want to run a previous webinar on it, so yep, we can share that link. Another question that just came in was, can I run real-time, like a real-time query on the database, and if so, like how does that impact the performance of my operational transactions?
Yeah, so depending on the nature of that query, like if we're writing a query that's a multi-table join going after, you know, millions of rows, certainly a SQL query could have impact on an OLTP transactional type system. So that's something that would need to go into the design. But again, because of the nature of NuoDB and our multi-TE flexibility, you can assign a TE to a query that has lots of memory, and you can pre-warm that cache to ensure that that SQL will run as fast as possible. But if it is going against the same database, then you know, all rules apply. That it is, you know, we're a you know, very you know, we comply to all of the ACID properties, so we're going to process that transaction in its isolation layer, and it's effectively its snapshot. It will see the data at that time and run that SQL even while other transactions are running. So something to consider when you're planning your deployment.
Okay, great. And I think just to emphasize, right, NuoDB is meant principally as an operational database. It can run some, you know, real-time queries, et cetera, but it's not meant for long-running queries. That's not a use case we typically recommend, right?
That's right. That would be sort of more of that analytical type of workload where, yes, Larita is exactly correct. We're really focused more towards that you know, high processing OLTP transactional type of workload.
Great. Okay, so, you know, looks like we've run out of time and questions conveniently. So thanks to Joe for the great presentation, the demonstration, and thanks to all of you that have joined us and attended our session. Hopefully we made it interesting and that you learned a little bit of something new with NuoDB. And if you have any questions that we didn't get a chance to answer today, please feel free to send them along to info@nuodb.com. We'll be sending out a recording of this webinar afterward, and we look forward to seeing you on a future webinar. Thanks so much. Bye-bye.
Thank you.